Hey, I know you're already running out of time and you have just a few minutes to check on AP. And I'm sure you have this kind of a look when we talk about arithmetic progression. Maybe after you watch the entire video, your looks might change to this. So let's get started. Let's define arithmetic progression. It's also called as AP in short. So it is a sequence of numbers arranged such that the difference between any two consecutive numbers is always constant. So for example, in this sequence, you have number 9, 6, 3, and so on. So the difference if you see between 9 and 6, it's going to be minus 3. If you subtract 0 from 3, you will get minus 3. Similarly, minus 9, if you're going to subtract minus 6 from it, you would get minus 3. So as we saw that the difference between any two numbers is constant, which is equal to minus 3. The dot on both the sides indicate that the numbers do extend on both the sides, and so it is called as an infinite AP. In this second example, if you see the difference between the two numbers, let's say 1 upon 10 minus 1 upon 5, you'll get the difference as minus 1 upon 10. Similarly, 1 upon 15 minus 1 upon 10 will give you again minus 1 upon 10, and so on. So if you subtract any two consecutive numbers, the difference would be minus 1 upon 10. Now what you need to remember is you have to subtract the preceding number from the successive number. So when you consider 1 upon 5 and 1 upon 10, 1 upon 10 is successive and the number preceding to that is 1 upon 5. The difference is denoted by the letter D. So in this case, D is equal to minus 1 upon 10. Depending on the sequence of numbers in an AP, the difference D can be positive or it can be negative or 0. The general form of any AP can be written as A plus D, A plus 2D, and it continues like that. A is called as the first term, and since we know the difference between the two consecutive numbers is D, the second term would be A plus D. So if the second term is A plus D, the third term would be A plus 2D, because you would be adding D twice. So if you have A plus D and then you're adding the difference again to the third term, so it becomes A plus 2D. You can also denote the sequence of numbers as T1, T2 up to Tn. So Tn is the nth number in the sequence. The first term here is either A or T1. The nth term, that is the term at the nth position, would be Tn. So it's denoted by Tn. The term at the n minus 1 position is denoted by Tn minus 1. The common difference D could be T2 minus T1, or it can be Tn minus Tn minus 1. If you want to know what is the term at the nth position, the way to find it is Tn is equal to A plus n minus 1 D. The easier way to remember this formula is you always take the first term, that is A, and then you add D n minus 1 times. So if the number is at the nth position, you would add D n minus 1 times. If the number is at the third position, you would add A plus 2D. So it would be n minus 1. So 3 minus 1, that is 2. The formula to find the sum of the first n terms, so it's denoted by capital S, is n by 2, 2a plus n minus 1 d. I'll repeat the formula. The sum of first n terms, S, is equal to n by 2, 2a plus n minus 1 d. In this example, the number of terms in the AP are limited. So this is called as a finite AP. Let's find the sum of the first 4 numbers using this formula. So we have n is equal to 4, A, that is the first term, is equal to minus 6, and the common difference D is 3. Let's substitute all these values in the formula above, and by using the Bodmer's method, we need to solve this equation. So we get the sum of the first 4 digits is minus 6. So that's all for now. Hope you have subscribed and liked the video and press the bell icon. I'll cover the complex problems on AB in my successive videos. So guys, my only advice is study hard, play harder, and have lots of fun. Sooner or later, success will definitely follow.